Hello and welcome to the second video in my Avro Manchester build. So, we ended the last video with the wing complete. So we are with the wing. And the second step I said would be doing the fuselage. I have constructed 95% of the fuselage. It was quite a long, lengthy process, so I didn't video it. It was quite challenging. But this is our basic fuselage. Again, like I said in the last video, it's the same plans as my Avro Manchester, so it's pretty easy for me to follow because I could roughly remember how I did it. So that's finished, just got to run the iron a bit over some edges to clean them up. And last night I built the tail plane. So here is the vertical and horizontal stabiliser, and the egg-shaped vertical stabilisers are obviously a lot smaller on the Manchester, so I had to redesign them to fit better and look better. So they're done, and I have the central vertical stabiliser that goes onto the fuselage. So I'll cut a slot in the fuselage and slot it in wherever appropriately. Looks really weird because in my head still it should look like a Lancaster, but it's obviously not. So the next part I'm going to do is we're going to cut the slot in the fuselage to fit the tail on. So I'm going to do that now. So yeah, let's crack on with that. Okay, so I've just spent a bit of time adding a bit of piano wire in the elevator to give it a bit more strength. I've added a control horn in the centre that's bolted through to the other side, you can see. And I've just created a extended push rod, so a bit of pine down here, square down, bit of push rod on each end, bound with cotton thread, super glued, and that's really solid. I did a bend in the end of the push rod, drilled through the wood, pushed it through before I bound it, so it's really solid. That makes a nice lightweight but strong and stiff push rod, because I'll have the elevator servo in the centre of the fuselage like the Lancaster, so it keeps all the weight at the front. So now what we're going to do is fit it onto the fuselage. So I've already gone ahead and cut my slots and test fitted it, and it all works okay. So now we'll just feed that push rod down in there. There we are, one tail section fitted. So now, while it's in place, I'll glue each side, just ease it up a bit, push a bit of glue in, secure it in place. The elevator's working nicely, it's clearing the fuselage nicely. So I'm going to secure this now. You may be thinking now I'm going to connect the servo inside, once now the push rod's in. Well, I'll be doing similar to what I did with the Lancaster. The belly, where the Bombay would be, will be able to be removed on a hinge, and once the wing is installed I'll be installing the servo onto the back of the wing, and then I'll be able to connect the push rod to it. So once I glue the tail on properly, I'll be installing the central vertical stabiliser. Now it's really starting to look more like a Manchester, isn't it? So I'll get this glued in first, and I can work out where this wants to be, cut a slot out and secure it into the fuselage. Okay, so tail installed, mid stabiliser fitted as well. So that is all good to go at the moment. So the next thing I'm going to be doing is taking the wing tips off the wing and marking where the wing needs to be put through the centre of the fuselage. Then I'll be cutting out that section, sliding the mid-wing section through, securing it in place, so that will obviously stay on the fuselage. And after that we can look at the engine pods and retracts. So we are well on our way with this project, it's going really nicely. I have also got, show you, contacted Sarek Hobbies online, and they do a 72-inch Lancaster plans, and they also do vac form canopies for it. So I ordered the canopies, you can just about see them. So we've got the main cockpit, front turret, bomb aimers window, rear turret and mid upper. So we won't be needing the mid upper because this Avro Manchester hasn't got one, but everything else is same as a Lancaster essentially. So got them ready to go. So let's get on to fitting the main wing. Manchester is really coming along now, isn't it? So, tail's complete for the moment. Central part of the wing is securely installed into the fuselage. So the next thing I'll be looking at, I think, is motor pods, engine pods. So I'm going to go print the plans off of that now, get them cut out, and we can start building them. Okay, so I've printed and cut off one of the motor pods. So I'm going to start breaking out the bits that I need to, folding it and gluing it together. Okay, so the next thing I've got to do, now I've pretty much finished the fuselage, is the motor pods and motor mounts. So I've printed off my standard Merlin motor pod for the Lancaster, and as you can see I've modified it to become a Vulture motor mount. So I chopped off the front of the Merlin one, the excess part that I didn't need, to accommodate my 3D printed engine cowling. I also needed a way of mounting the motor. On the Lancaster I've just got a bit of plywood, motor screws straight onto the plywood, and then the shaft just protrudes out the front of the engine cowling where the front of the Merlin would sit. But with because I've got a 3D printed cowling, I needed to extend the motor mount a little bit to put the motor onto. So I was thinking, how can I do that? Because the motor is nearly sitting right at the top of my engine pod. So I had a bit of play on Fusion 360, did a design of a extended motor mount, and I printed it in PETG, which is a really strong plastic. It's a lot stronger than PLA and PLA Plus, which I normally use. A little bit heavier, but I'd rather sacrifice strength for weight any day. So here we have a 3D printed motor mount. I'll get myself out of the way and it'll focus. There we go. So that just goes inside engine pod, glued in there with a strong adhesive, a little bit of hot melt glue on the sides just to secure it while it was going off. Motor is screwed onto the end there, as you can see. It's a flight test radial C motor that came up my P38 Lightning. So that is really strong and bonded on there, really tough as well. So it should take, PTG can take a lot more vibration and high temperature than PLA can, so we should be fine. And didn't plan this, but it's come out really well, that the edge of the mount where it sits on the motor pod is exactly where the cowling sits, so it locates perfectly when it sits on there and sits, and the motor is just protruding out the end there, so it'll get a nice amount of cooling and it'll look really cool. It kind of looks like a radial engine, which I think that's what flight tests were going for when they designed the motor looks. But I've also got really nice cooling intakes where the radiators would have been on the Manchester. I'll be able to put the ESC for the motor right behind them, so it'll get lots of air passing through it. I'll be covering that part how it would have been. I'll probably just straighten it to where the landing gear goes in this pod. So I'm going to start building this up, make it look good, and then I'll need to cut out a piece of plywood once I've stuck this onto the wing that goes in the base of this motor pod where the landing gear will attach, nice secure hard point. So yeah, I'm going to get this attached properly now, and then I'm going to get these attached to the wing. Okay, so you're about to catch me at a very exciting moment. As you can see, the engine pods are done. One is securely fitted to the wing. Here we've got the other one. All mounted up, looking really cool. Got these back pieces to attach once this is all installed, and once I've got the landing gear installed and how much I know that it will overlap. So I'm now going to install this one onto this wing, and it's really taking shape. It's really exciting. So I've got a box underneath here so I can really push down on it and secure it. Glue gun is full and ready to go. Put a really healthy bead of glue, really hot. So I'm lining it up on the edge of where the dihedral starts there. And make sure I pin this down nice and hard so it really gets a good bond, because you really don't want this sort of thing falling off. In flight, taxiing, wherever, it wants to stay on. Once this is secured a bit nice and hard, I'll run a nice clean bead down both sides to clean it up a bit, seal the gap. I must say them engine nacelles look absolutely fantastic. Oh yes. Now it's looking Manchester-y. Oh yes, that is looking awesome. Yeah, I'm really happy with that so far. It's really coming together well. Top of the, now these are fitted, I can do the top of the engine cowling. There you go. Right. Meets onto the wing. Nice smooth clean finish. Both sides. Nice to get some tri-blades on this to see how it looks. Yeah. The front of the fuselage to finish off. Obviously got the retracts to look at and tail wheel. I showed you the other day I got my vac form canopies ready to go. Yeah, it's actually coming together really quickly, really nicely. I need to cut out the bomb bays at some point so I can put all the electronics in, wire up the two motors. The ESCs are just taped in here at the minute. They'll be sat just behind these radiator intakes so they get really nice cooling when it's flying. Yeah, really come together well. Love foam board, it's such a versatile material. Nice and light, really lightweight at the minute. I'd say it's probably about a kilo, maybe a bit less than a kilo. So that's nice. The Lancaster's all up weight is 2 kilos with the 2 battery packs in it, with the system battery and the motor battery. So this, obviously having just 2 motors, it should be a bit lighter. But I think with the 3D printed motor mounts that I've done, it might work out the same. So I'm aiming this is probably going to be around 2 kilos, probably just under. I should be able to run everything, system and motors, on one flight pack, probably the same 4000 4S, just to keep it simple. I only run the Lancaster with a system battery just because if I lose the engines, lose the battery for the engines, it will still be functional because there's a separate battery running all the servos, receiver, the lot. So like I say, if the motors go down, I can still glide it. Whether it will want to glide or not is another matter, but thankfully I've never had to come to that problem. But I'll run this on one singular battery because at the end of the day, P38 Lightning and on one battery. I ran it on a 2200 4-cell, same as my FT210 chase drone, and they used to last about 10 minutes. So on a 4000 pack on this, it's easily going to cream 10-15 minutes easily. So that's where we're up to at the minute. So in the next video I will show you hopefully the finished off motor pods, and we'll move on to retracts next, I think, so it can sit. And once I've worked out the retracts, I'll be able to work out the wiring, threading the wiring through the wing into the fuselage, linking up the servo to the elevator control, and obviously I need to install servos into each aileron, thread them through the wings as well. So there's a lot of wiring to do. So retracts next in the next video. So thank you for watching, thank you for the support as ever, and until next time, happy flying, keep safe.